Supermarkets are truly one of the modern marvels that play a major role in making our everyday lives more convenient. They provide us with almost unlimited supply of goods with an unbeatable price tag. This wouldn't have become possible without the power of modern automated manufacturing. These manufacturing plants, with their seamless production and packaging lines, can run with the highest efficiency and speed to supply the market demand while maintaining the lowest price. Most of the modern manufacturing plants around the world use computer programs and simulations to design and manage their continuous manufacturing lines. Although there are professional-level softwares available for this purpose, but they are often complex and also aren't rich in graphical interface quality. This makes teaching the manufacturing concepts to an untrained and uneducated person hard and confusing. In today's presentation, we are going to create a virtual manufacturing plant simulation aimed at training high school and early college students with the concepts of manufacturing management to encourage those students that are interested in these subjects to apply for higher education in the related fields. My name is Ali Ahmadi Beni, and I'm presenting our project, Virtual Environment Manufacturing Plant Discrete Event Simulation for Interactive Production Line Management. Before we start, I would like to thank my teammates Brandon, Faraz, Grace, and Khaybarullah for their help and cooperation, and also our instructors Dr. Chimba and Dr. Hargrove for their valuable comments. First, I want to talk about the reasons why this project idea has formed and why it is a good idea. The initial idea of this project started when I was taking manufacturing management course back in my master's degree, and throughout this class, I was thinking what if there was a computer simulation that could teach the concepts of timing in manufacturing plants with an immersive experience. It could help other students and even high school students to grasp these ideas before they are exposed to the university major or getting hired for the job. I know I have a three-dimensional mind. I need to imagine things in a three-dimensional space before I understand them. I even need to imagine math formulas before I understand them. And I know a lot of people are like this. And for those people, experiencing and seeing can have better learning impact than theories and formulas can ever have. I also think there exists another very good yet unpopular method of teaching new concepts out there, by giving the learner the ability to dismantle the system and then trying to fix it. And this is how our brains evolved when we were babies. This is also how I learned how to fix cars by accidentally breaking a bolt in my car's engine head when trying to replace my alternator, and then left with no choice but to disassemble the engine. And that was a very painful yet insightful experience. I'm sure all of you have had such experiences happen to you, where you almost felt like you can teach other people how to do something after you messed it up and then try to fix it. I'll get back to this idea later on the video. Manufacturing plant simulation softwares have been around since the computer graphics were first introduced. But they were and still are very poor in graphics and very hard to understand by a beginner. Some manufacturers have acknowledged this issue. For example, Ford designed a virtual reality simulation to help its mechanics with how they assemble their car parts. According to Reuters, more than 41% of teenage boys and 20% of teenage girls in the United States play video games every day. Some of that time on video games can be redirected to learning time through the proper video games. In this project, we will try to create a first-person view virtual environment and use the concept of manufacturing plant simulation to give the player the ability to control their surrounding manufacturing machinery and see the effects of their actions on the environment. By trial and error, the player can find out why timing on seamless manufacturing plants is one of the most important factors, and how they can control that. To create this simulation, we primarily use Unity software. Unity is a 3D game engine software that provides the user with prefabricated tools and functions to create multi-platform games, meaning you can export your game for PC, gaming consoles, and mobile phones without major changes in the game design. 50% of the games nowadays are created using Unity. Unity uses C# programming language as its primary coding and function programming language. Unity is a free software available to download at unity.com. Sebastian Lau is one of my favorite YouTubers who uses Unity to create complex simulation and graphics using C# code, and I highly recommend you to check his videos out. Now let's dive into the game creation. This version of the simulation is mostly based on the minimum amount of coding and design complication, so that any person watching it be encouraged to give Unity a try. Let's start with Unity. Here in the center, we have the 3D environment viewer. On the right, we have the modifiers and options, and on the left, we have the object list. And in the lower section, we have the asset list and animation tabs. Unity also offers a very rich asset store inside the software that you can download pre-made packages to use them in your own projects. I bought this package through a promotion around 2 years ago, and it is amazing. It provides you with a variety of sci-fi theme objects to use in your own environment. I'm going to create a hallway with the access door to the room. This room is going to be used as a manufacturing plant. At this point, I thought that would be a lot cooler to have a reception room before going into the manufacturing plant. This laboratory pack that I downloaded is packed with various objects. This makes it so much faster and more interesting to design 3D environments compared to designing and texturing everything all by yourself. And now I'm trying to make the reception room a little bit more interesting by adding a few objects to it. I'm also putting a trash can here by the desk, and also a lot of used coffee cups here to make it look like my own computer desk in the days prior to this project due date. Some oxygen gas containers look good in this corner too. At this point, our virtual environment is ready to have a walk inside it. Unity offers first-person and third-person game views with their keyboard controllers as pre-made packages. The Unity standard package, available through Unity Asset Store, has this camera system included. Now let's add the character and let's see if everything works good. And yes, it does. Now that we have finished with creating the plant, I'm going to start creating a conveyor belt system. After so much trial and error on creating a good-looking conveyor belt, I found this package that sells for only $5 on the Unity Asset Store. This package includes a variety of animated conveyor belts that would work with any object that you want to throw at them. And now let's start creating the conveyor belt system. I replaced the edges of the conveyor belts with solid plates. And here I'm adding a few directing parts to the conveyor belt. I'm also adding these parts so that each object can move in a straight line. This device is supposed to work as a printing machine that prints out expiration dates on the cans. Of course, this is just cosmetics. Also adding a few plates to conceal the entrance conveyor belts inside the wall. And this gas container from this package looks really cool to be used as a support columns beneath the conveyor belts. And here I'm doing a few more small adjustments and additions to the room. Now adding ceiling and finishing the wall panels to look seamless. Now I'm adding some walls to the exit hole, so it looks like the cans are going to be dropped into another conveyor belt in the next room. Now adding some more cosmetics, some pipeline, a door, this alien looking machine in this corner, and a few ceiling lights fixtures. For this production line, I'm going to choose a Campbell chicken soup that you can find in any supermarket. I'm using a cylinder object from Unity and applying the Campbell soup texture that I found on the internet. Now let's get into the C# part. I add an empty object from Unity which equates the null variable in programming languages. I'm going to use the location of this empty object to spawn the cans. First, I define the object and time variables on the top. Then using the spawner function, I'm instantiating new cans at the empty object's position at the defined time intervals. Now let's put some controllers in the scene. First, I want to be able to move this divider part back and forth to increase the length of the conveyor belt in cases of increased production speed, and also be able to fully close it to halt the operation and trap the food cans behind it. I'm using the cylinder object and shaping it like a huge pill. Then I add my textures. Now I am writing the code to get the center of the screen and cast an invisible ray when you are clicking the mouse. When you click, if the ray hits any of the buttons on the scene, their function will be called. I'm also using two more empty objects to use them as position guide to move the divider towards them. Now I'm adding a few more controllers to the scene to adjust the timing of the spawning. I use the same pill-shaped buttons and apply related textures for increasing, decreasing, randomizing, and resetting the time settings. The default spawning time is set at 1.9 seconds, which I came up with it after dozens of trial and errors on the smoothest way the conveyor belt system I designed works. After defining the game object variables, I'm adding functions for each button and then connect the functions to the button click if statement. The increase and decrease buttons are set to change the time by 0.2 seconds on each press. Let's check out the buttons. They seem to work pretty fine. After seeing this many food cans on the scene, we need a way to destroy them from the memory when they exit the other side of the conveyor belt. Otherwise, they will drain the computer RAM quickly and make the game super slow and cumbersome. In another C# code, I'm just adding a trigger destroyer which deletes any object that comes in contact with the destroyer. And then I assign the code to an empty object and put it beneath the last conveyor belt. To make the experience a little bit more interesting, let's add some sound to the buttons. From the Artlist website, which is my favorite website for downloading music and sound effects, I'm downloading a beep sound. And then assign it to all the buttons. I also want to add a screen that shows the exact spawning time. This was my first time using variable text in Unity, and after a small Google search, it wasn't hard to write the code. I also downloaded this calculator screen font to make the timer look more digital. Now this screen looks a little messy. I need to round the decimal points to 2 and decrease the font size, and I need to assign the text update function to each of the buttons. Now let's move the position of the spawner empty object to where it's supposed to be and test for timer and buttons. Everything seems to work pretty fine as intended. In this part, I'm adjusting the dividers and directors to smooth the movement a little bit more. I'm also adding more edge to the conveyor belts since I saw some of the food cans can slip out of them. I thought there was also a need for the word interval on the screen so that the first-time user can better understand and connect with the timer. Now I'm adding the TSU logo and our names in the lobby area. And what is left is to make the environment look better. And that means more texture and better lighting. Unity is one of my favorite softwares because it offers real-time lighting of daylight in your scenes. But since this project is defined inside the building, I'm going to remove the sun from the environment and add some lights to the scene. Considering a science fiction theme of the environment, a dark and spooky lighting works great with the hallways. But for the manufacturing room, I prefer brighter lighting. I also assigned the manufacturing plant ambient noise to the manufacturing room so we have the better experience of a manufacturing area. And finally, everything seems good. Let's export and run the simulation. When we run the simulation, we are going to be spawned in the back of that hallway. And after a short walk, we arrive at the reception room. Then we can move into the manufacturing room. By the time you arrive at this position, the conveyor belts have already moved a few cans to the line and you can observe their movements. This line is designed to momentarily store and slow down the can's movement in this area. Then the barcode is printed on the cans and they are separated in batches of 2 in this section. The 1.9 second default spawning interval is set for this 2 can separation here. One exercise for the user is to adjust the time in a way that the cans are separated in batches of 3. And now going back to what I said about letting the students learn by dismantling the system. I designed a perfectly working system, and now they are given the chance to make a mess here. They can close the gate or decrease the spawning interval to an overwhelming point for the conveyor belt system. The good news is that everything here is designed to be reversible, meaning by changing the setting to the initial state, or let's just say a rational state, the manufacturing line can come back to business very fast. Hopefully, after using this simulation, the user can have a better understanding of how timing and speed of each component in the manufacturing line can impact the subsequent parts of the line. And this was our presentation. I would like to thank you for taking your time watching this video, and I hope you enjoyed it. This simulation was done using the computers in the Center of Excellence for Battlefield Sensor Fusion Laboratory at Tennessee State University.